All right, let's jump right in. The oil and gas industry has this massive, multi-billion-dollar problem. A huge chunk of oil gets left stuck in the ground. But what if the key to unlocking it wasn't some giant new drill, but an algorithm? Yeah, that's what we're digging into today, how AI is being used to find this gigantic, trapped resource. So picture this. You find a treasure chest, right? You open it up and it's full of gold. But there's a catch. You can only get about half of it out. The rest, it's just stuck, glued to the sides, and you can't scrape it free. How frustrating would that be? Well, believe it or not, that's pretty much the exact situation happening in oil wells all over the world. See, after we pump out all the easy stuff, a huge amount of oil is still down there, trapped in these tiny, microscopic pores in the rock. And the whole mission to get that leftover treasure out, that's called increased oil recovery, or IOR for short. And we're not talking about a small amount here. This is billions of barrels of oil. I mean, it's a massive economic and energy resource just sitting there, totally out of reach. If we could get even a tiny fraction of it, it would be a total game changer. But first, we've got to understand, why is it so stuck? It all boils down to some basic physics, really. You can think of it like this molecular stickiness that's literally holding these little oil droplets hostage inside the rock. They just refuse to let go. So, to get the oil out, you've got to find a way to break that bond. And that brings us to the big scientific term for the day, interfacial tension, or IFT. It sounds complicated, but you see it all the time. Just think about salad dressing, right? The oil and vinegar always separate. That's IFT. It's this force at the boundary between them that just keeps them apart. Now, down in an oil well, that same force acts like a tiny microscopic cage, trapping the oil and stopping it from flowing. So if the IFT is high, that force field is super strong. The oil is locked down tight. But what if you could inject a special chemical fluid that just tanks the IFT? Well, that force field gets super weak, the oil droplets break free, and you can finally sweep them out. So the whole game, the entire goal, is to get that IFT number as low as you possibly can. Okay, so the mission is clear. Lower the IFT. But how do you actually find the perfect chemical cocktail to pull that off? Well, for decades, the way we've done it has been painfully slow. It's been all about manual guesswork, just mixing and testing, basically hoping you stumble across the magic formula. And when I say slow, I mean incredibly inefficient. You'd have a scientist in a lab manually mixing up a few chemicals, running this long, expensive test just to get one single data point. And to find the best formula, you'd have to do that hundreds, maybe even thousands of times over. It's literally like trying to find one specific key in a giant room with a million keyholes, and you're testing them one by one. It's just not practical. But this is where things get really interesting. This is where the story takes a sharp turn. Instead of continuing to guess in the dark, researchers thought, what if we brought in a tool that could see the patterns we can't? And that tool was machine learning. They decided to teach an AI how to predict the perfect recipe. And this new approach is a total game changer. I mean, think about it. Instead of spending weeks in a lab just to get a handful of data points, you could feed all that existing data to an AI. The goal? To build a model that could instantly predict the IFT for any chemical combo you could think of. You're not doing one test at a time anymore. You're doing thousands of virtual tests in the blink of an eye. Now, the researchers didn't just pick one AI and call it a day. Nope, they basically held a bake-off. They tested a whole suite of different machine learning models. You had some simpler ones that look for basic connections, and then you had these really complex ones designed to understand all the subtle, tricky ways these chemicals interact. It was a straight-up competition to see which AI could predict the results the best. And after all that training and testing, the results were absolutely definitive. One model came out as the clear champion, the undisputed winner. And it didn't just win, it led them straight to some incredibly effective new formulas that could finally hit that target of ultra-low interfacial tension. Okay, so just look at this. The results were staggering. What you're seeing here is the prediction error rate, and obviously lower is way, way better. So that first model, PCA, wildly inaccurate, totally unusable. The next couple, SVM and Kriging, they're better, but still pretty far off. But then, look all the way at the end, ANFIS. It has a tiny error of just 1.8%. I mean, this wasn't even a competition. One model was just in a league of its own. So why was ANFIS the clear winner? Well, it's because it has this really cool hybrid design. It combines neural networks with something called fuzzy logic, which made it perfect for understanding the super complex, messy relationships between all the different chemicals. It ended up being over 98% accurate. It was exactly the reliable crystal ball they were looking for. So now, with this incredible prediction tool in hand, the researchers could just blitz through millions of possible combinations to find the absolute best ones. And here you go. These are the actual concrete results, the winning recipes that the AI uncovered. These are specific formulas that got those IFT values crazy low, something that, yeah, would have been pretty much impossible to find the old-fashioned way. And this is the magic number. The goal was to get below zero point 0.1, and the AI-guided models did it. They found formulas that hit that target, which is the threshold for what's called ultra-low IFT. That's the level you need to really get that trapped oil moving. So they didn't just make the process a little better, they totally hit the jackpot. So the big takeaway here really goes way beyond just oil. What this proves is that AI can be an unbelievable partner for scientists. It can speed up discovery, save a ton of time and money, and find solutions that are just buried in mountains of complex data. It really makes you wonder, right? What other secret recipes are out there? For things like new medicines or better batteries or new sustainable materials, just waiting for the right AI to come along and find them?